Hello students, so today I am going to teach you how we are going to simplify the example, that is maxima and minima. I am going to teach you today two very important examples, that is find the extremum value of f of x, and we see this function how we are going to simplify, and one more example, that is examine the function sin x plus sin y plus sin x plus y for extremum values. Yes students, before solving this example you should know the method. I'm going to tell you how to use the method, and one by one we are going to simplify this examples, very important examples for examination point of view. Watch the video till the end. I'm going to start here. Working method for maximum and minimum, even we call it as maxima and minima. So let the function f of x comma y be given function. Step 1, we are going to start the steps. So first step is find dou f upon dou x and dou f upon dou y. Immediately when you find this, easily we can see that in this with respect to f, if you differentiate this partially with respect to x, y we are going to keep constant, and when you differentiate f with respect to y, x is going to become constant. Keeping this in mind, we'll go to the step 2. So please remember this students, solve the equations dou f upon dou x is equal to 0 and dou f upon dou y is equal to 0. Whatever the equations we are going to simplify here in this step 1, I'm going to just equate this equal to 0, and then we will come to the points. So simultaneous points we get it as x1 y1, x2 y2 and so on. Then let be these points. Then immediately we'll go to the third step. So we're going to take let a is equal to dou square f upon dou x square. We are going to find the value of a. Then next we are going to find the value of b. B is equal to dou square f upon dou x dou y, and we are going to find the value of c is equal to dou square f upon dou y square, and calculate all the values a, b, c for each point. So depending on how many points are there, suppose in next example you see that there are 4 points, there are 6 points, some of them some of the exams you're going to get the 8 points. So all 8 points we are going to simplify the a, b and c values. The next we'll go to the step 4. We can see very easily if the points x1 y1 which we have solved, if we have ac minus b square is greater than 0 and a is less than 0, then the function f x comma y is a maximum for this pair, and maximum value is f of x1 y1. Yes students, you can see if this condition satisfies, then this point is going to become a maxima, and for this point we are going to find the maximum value in the function f of x1 y1. Suppose in what cases, in some of the cases, if for point x1 y1 we have ac minus b square greater than 0 and a is greater than 0, then in the such cases f of x comma y is minimum value, or we say it as minima. I'll just take it as minima for this pair, and minimum value we are going to find using the function f of x1 y1. Suppose in some of the cases many students ask that if ac minus b square is greater than 0 for the point x1, then there is neither maximum nor minimum. So I'll just take this as okay. Suppose if there is no maxima and minima, then we just say it as the function is saddle at x1 y1. So like this we have the following steps. So now we'll go to the example. Yes, stay tuned to the end of this video lecture students. If you like this video, please like, subscribe and share with your friends. Let them also pass the examination students. Yes. Yes friends, now we're going to solve this example keeping the method in the mind. Immediately I'm going to take the function, take the function given f of x comma y is equal to, I'll just multiply this x cube y cube in this bracket. I'll just open the brackets. I will get this as x cube y square minus x raised to 4 y square minus x cube and y cube. This is a very simple function we get. Now we shall take the points and find where xy belongs. So we will just find points x comma y, okay, such that, so this is our step 1, where we can see f of x is equal to 0 and f of y is equal to 0. So let us simplify one by one. So everyone, you know, fx is equal to 0. I have just shown in the working rule that this is fx is equal to, so keeping in the mind y is constant, I will just differentiate with respect to x. So x cube differentiation, I will get this as 3x square y square as it is, minus differentiation of x raised to 4 will be 4x cube y square as it is, because it is constant, students. Then this is minus x cube differentiation is 3x square y cube. So y cube is constant, I will write it as it is. Similarly, we are going to differentiate this partially with respect to y. Please remember here, students, x is constant. So let me differentiate this here. Y square I am going to differentiate. X cube I will keep it as it is. So it will become 2x cube y minus, here you can see, students, x raised to 4 will remain constant. Therefore only y square I am going to differentiate. So it will become 2x raised to 4 y. Similarly here minus x cube is constant, I am going to differentiate y cube. So I will write here minus 3x cube y square. So like this we will simplify the differentiation. Now what we are going to consider here, yes students, in the next step I am going to consider here fx is equal to 0 and fy is equal to 0. Consider this two. So then easily you can find the equations one by one. So let me equate this. In the fx, you can see what is common in this, ones. You can very easily see there is common x square y square is common everywhere. This is x square y square, x square y square, and x square y square is common. So if I take out x square y square, if I take out, what will remain in this, ones? Only 3 will remain. So I'll write this 3 here. Then in this case what will remain? Minus 4 will remain, and because x square is removed, so because here x cube is there, 1x will remain, so I will take it 1x. So x square is outside and y square is outside the bracket. The next I will continue minus, here again I will take the minus 3. Here x square and y square I have taken outside common, so x square is gone, only y cube is here. So y square if you remove, only remains y, which is equal to 0. And similarly I will take here common x cube y. So if I take, in this case if I take x cube y outside, so what will remain here, students? X cube y is outside, so in this case it will be only 2 will remain, minus 2, x cube is outside, so 1x will remain, and y I have taken outside common, so y I will take it out, minus 3 will remain here. In this case here we can see very easily x cube is taken outside, so y square remains, y square, y 1y is outside, so remaining 1y is inside. Now this is going to become equal to 0. So like this we can find the points one by one. So now you can see very easily here in this case, in this equation, here you can see, students, on the screen, here when this term is going to become 0, there are the cases that either x is 0, this full equation will tend to 0, or the value of this equation will become 0 whenever x is 0. Similarly if x is 0, this is 0. Next y is 0. So if y is 0, the full equation will remain 0. So therefore 0 into anything is 0, therefore y may be 0, or yes students, or the remaining term is this is 3 minus 4x minus 3y is equal to 0. So either of the three cases, if one is true, this full equation will remain 0. So I will just simplify this, minus 4x minus 3y, I will bring it on this side. So therefore I will get this as 3 is equal to 4x plus 3y. So minus will become plus, you know that. So from this first equation we get this 3 different answers. Similarly and I'm going to simplify the next one, friends. Easily you can tell me what all things will 0. First x is 0, this full equation will remain 0, therefore x may be true. Next I will go to the next variable, that is y. Here if y is 0, the full equation will remain 0. Yes, or yes students, or we get 2 minus 2x minus 3y must be 0, so that the full equation will remain 0. So minus 2x and minus 3y, I will bring it on this side. I will get this as 2 is equal to 2x plus 3y. So like this, any of the three cases are 0, this full equation will remain 0. So let us form the pair of equations. So let us form the pair of equations, friends. If you see the form of pair of equations, as you can see x and y, we always take the pairs of equations. So either x must be 0, y must be 0. Let us see how many pairs we get here in this case. Okay, so we'll just see in this point very easily. So first point, easily we can pair with x and y. So what all pairs I will get? The x comma y points. Okay, we'll start with one. I say that x is 0, y is 0. So let us make pair of points, x and y 0. Next pair, So what will be the next pair? Yes, I will take first x 0 and this term 0. This term I will take it 0. So therefore you get here x 0 and 4x plus 3y is equal to 3. This is second pair I get. Similarly, I will take next term. Either I will take 4x plus 3y is equal to 3 or y is equal to 0. So like this, I will get the 3 pairs from this 3 equations. I will take this 1, I will take this 2 equation, and I will take this 3. So it is 1 and 2 I have taken. In this case, the equation I have taken 1 and third equation I have taken, and in this case I have taken 2 and third equation. So like this I have to pair all the equations. Similarly, I will move on to this. I will call this now fourth equation, I will call this as 5 equation, and I will call this as 6 equation. So again I am going to pair this. I will continue this here, students. Again in this case we can see very easily equation 4 and equation 5. I will take only 2 equations and I have to find the pair of equations. Yes, I got x and y pair. Similarly, I will take 4 and 6. Let me take 4 and 6. We'll take 4 and 6 pair of equations. So we'll take x is equal to 0, 2x plus 3y is equal to 2. So remaining I will get this as 5 and 6 equation, that is 2x plus 3y is equal to 2, and I will get this as y is equal to 0. So here we can easily see here, students, how many equations I get. 1, 2, 3, 4, 5, 6 points. Yes, students, how many points? These points are known as stationary points. So therefore the stationary points are, so how many points we'll get? We'll write all the points in terms of x and y. So let us start with finding x and y one by one. So now first we can see very easily x is 0, y is 0. So in first point and the fifth point are same, so I will not repeat the points. Is it clear? So let me take only the similar points. Now in the next case we can see very easily this x is 0, we can directly take x is 0, but why we don't know. So I will put here x 0, so it will become 4 0 plus 3y is equal to 3, or y is equal to, I will get this as 3 divided by 3, it is 1. So let me take this as 1. Similarly here in the next case, 4x plus 3y is equal to 3, this is y is equal to 0. Y I will put here 0, so this will become 0. So I will get this as 4x plus 0 is equal to 3, and x is equal to 3 by 4. So like this I will get x is 3 by 4 and y is 0. So this first 3 points I got. Now similarly I will go to the next point. X and y is 0 0, so no change. I will not repeat. Now I will go to the next point, that is fifth point. It is 0, x is 0. When x is 0, so this will become 0 plus 3y is equal to 2, means y must be 2 divided by 3. So I will take 2 divided by 3 as y. So last point is remaining. Here y is 0. So y is 0. So you can see very easily this 2x plus 0, you will get here 2. So I am just substituting this value as 0. So therefore x is must be equal to 1. So x is 1, y is 0. So the last pair, yes friends, last pair I get from all these equations, that is 1 and 6. So that I will write separately. 1 and 6 is the last pair I get, that is 4x plus 3y is equal to 3, and next case is 2x plus 3y is equal to 2. To write this separately because we have to simplify this. Okay, so let us simplify and find x and y quickly. So I will just take this as minus. So these two equations will get cancelled. Automatically this will become 2x, 4x minus 2x is 2x. So which is equal to 1. Therefore x I got this as 1 upon 2. Now I will put x is equal to 1 upon 2 in this equation. So x is 1 upon 2. Therefore what I get this as x into 1 upon 2. I just want to find the value of y. So this is 2 and the 2 to the, so therefore 2 I will bring it on this side, this 2 will bring it on this side. So it will become 3y is equal to 3 minus 2, which is equal to 1. Therefore I get y is equal to 1 divided by 3. So the last point, stationary point, sorry, I will get this as x and y as 1 by 2 is x and 1 by 3 is x. So like this we get one more point, that is 1 by 2 and 1 by 3. So like this we get all these points. Okay, so when we get all these points, friends, immediately I'm going to substitute in the equation. We are going to find the next step. So we have done first step, dou f upon dou x, dou f upon dou y equal to 0 we have done. Now in the step 3, I'm going to take ABC and find the maximum and minimum. Yes students, we'll just find the maximum and minimum here. Okay, so here I'm going to take first A. I'm going to find A value, find. So this is going to become our step 3. So I'm going to find A, B and C. Let us find A, B, C first. So one by one I will take first A. What is A? We know it is f x x, or it is dou square f upon dou x square. So already we have calculated fx. So you can go through the previous slide and just see. I have got the value as 3x square y square minus 4x cube y square minus 3x square y cube. Just I am going to differentiate this once again with respect to x. So we can very easily see here only x square I am going to differentiate. It will become 2x. So 2 into 3 will become 6x. Y square remain constant, so I will write y square as it is. X cube I am going to differentiate. Then next it will become 3x square. 3 into 4 will become 12x square. Y square remain constant, and similarly I will get the last term, that is minus 6xy cube. So like this I will write here 6x square, sorry, x y square minus 12 x square y square, and then minus 6x y cube. Now in this friends, very easily we can see what is common. 6 is common everywhere, x is common everywhere, and y square we can see very easily. So what remains here? It remains only 1 minus 6 2s are 12, so 2 is common here. So x I have taken outside, so 1x will remain. Y square I have taken outside, so I will not write y square. Minus 6 is outside, I have taken common, so I will not take 6. X is common, so I will not take x. Y square is common, so 1y will remain in this case. So similarly I am going to find b. B is equal to fx y, where we can see very easily this is dou square f upon dou x dou y. So please remember here friends, this is differentiated first with respect to y, and then we are going to differentiate this with respect to x. So first I will substitute the dou f upon dou y. So it is already done, so just write down the same, 2x cube y minus 2x raised to 4 y minus 3 x cube y square. I'm going to differentiate this with respect to x now, so it will become our b. So therefore this will be here only x I'm going to differentiate, but whereas y remains constant, so 3 to the 6 6x square y minus, again here x raised to 4 I'm going to differentiate. X raised to 4 is 4x cube, so 2 into 4 will become 8x cube. Please remain, y remains constant, no change in y. Similarly here I'm going to differentiate x cube only, so therefore 3x square I get. 3 into 3 will become 9x square y square. So what is common here friends? So very easily we can see we have x square and y common, so we'll just take out x square y. If I take out x square y, 6 remains in the first case, minus 8x remains, and minus 9y remains. Similarly I will find f. F is equal to, sorry, c I'm going to find. C is equal to f of y into y, means it is dou square f upon dou y square. So y we know already, so I will take this function y. So y we have already calculated, it is 2x cube y minus 2x raised to 4 y minus 3 x cube y square. Then just I am going to differentiate this with respect to y. So therefore I will get this as 2x cube, here y differentiation is 1, minus 2x raised to 4. Please see here x remains constant, only y I am going to differentiate, so differentiation of y is 1, minus, here you can see y square only I am going to differentiate, so therefore it will become 2y. So 2 into 3 will become 6x cube y. So what is common in these two students? Yes, very easily you can see it is 2, x cube remains constant, so here 1 remains, minus x remains, minus 3y remains. So like this you simplify the example ABC. Now yes, now I'm going to see very easily that looking at the example, looking at the points, here we can see if you substitute all these points, so point 1, let me take, this is point 1, this is point PT, I'll say PT point, PT2, and this is PT3, PT4, and PT5, and this is PT6. One can very easily see if I substitute x is equal to y is equal to 0, automatically a is 0. If I substitute x is 0, y is 0 in B equation, again you will get B is equal to 0. If you substitute x is equal to 0, y is equal to 0 in equation C, you will get 0. So therefore only, again if you take point 2, x is 0, y is 1, again it is 0, all the three are 0. Again x is 3 by 4, y is 0, again all the ABC will become 0. Again if you take point 4, x is 0, y is 2 by 3, all the 3 points will become 0. Again if you take point 5, x is 1, y is 0, all the 3 points will become 0. Only point 6 remains as it is. So why it remains, friends? Very easily we can see that this ABC is a pair of x and y, means we can see here in all the cases we have x and y, x into y square, here we have x square y, and here we have x cube. So where we can see very easily all the three terms remains 0. Only in the case where point does not become 0, that is only the point number 6, where we can see very easily that 0.6, 1 by 2 and 1 by 3, where it is not 0. So when we will take now all the points and study maxima and minima. Finish. In 2 minutes we'll get the answer. A is equal to 0 or C is equal to 0. We can see AC minus B square is less than 0. So therefore we don't take this ACB. So directly I will take the point 1 upon 2, 1 upon 3. So in all the points from 1 to 5 points we get this condition. But when point 1 by 2, 1 by 3 is taken, please remember we get the extremum value. So we can just substitute in this, friends. A is equal to 1 by 2 and x is equal to 1 by 2, y is equal to 1 by 2. We substitute in this equation, friends. We get here A is equal to, this is 6. So substitute 1 by 1, x is 1 by 2, y is 1 by 3. So in the equation given 1 minus 2, I'm just substituting in A equation minus 1 by 3. Yes, friends, if you simplify you must get here minus 1 by 9. Similarly in B I'll substitute x 1 by 2 and y 1 by 3, and it is 6 minus 8, x is 1 by 2 and y is 1 by 3. If you simplify you must get here, friends, minus 1 by 12. Similarly you try for C. So it is 2 1 by 2 cube minus 2 1 by 2 is to 4 minus 6 1 by 2 cube 1 by 3y. So if you substitute all these points you must get this value. So now if you simplify this, therefore AC minus B square if you take, and if you simplify you must get this as 1 upon 144, so which is greater than 0. But A is equal to minus 1 by 9, which is less than 0. Thus we can see very easily, student, this is 0 and this is less than 0. We know that the point is going to become maximum. So 1 upon 2, only 1 upon 3, only 1 point we are getting maximum. So when you get maximum point, immediately the function is extremum. Therefore our minimum value of f of x comma y is equal to f of 1 upon 2 1 upon 3. Substitute in the function, students, x cube y square. So I'll just take x as 1 upon 2, so I'll just substitute here cube, and this is 1 upon 3 as y, and then 1 minus x minus y. This is function, therefore the maximum value must be 1 divided by 432. So like this easily you have to simplify, students. Next I'm going to simplify this example. So now here I will take the solution. So here I am going to take the function first. F of x comma y is equal to sin x plus sin y plus sin x plus y. So we'll go to the step 1. In step 1 I'm going to differentiate this f partially with respect to x. So therefore sin x will become differentiation cos x, plus we can very easily say that in this case y is constant, so sin y will automatically become constant, students. So therefore this will become 0, and we'll go to next sin x plus y. So it will become cos x plus y. So inner differentiation x plus y is 1. Similarly, I'm going to do the differentiation with respect to y. Here keeping in mind that x is constant, so sin x differentiation is constant, so sin y differentiation will remain cos y. So we'll get here cos y plus sin x plus y differentiation, we will get this as cos x plus y. So like this we differentiate with respect to x and y. So now we know that we're going to consider fx is equal to 0 and fy is equal to 0. So therefore this full term you can see on the screen here, friends, this is going to become 0, that is cos x plus y will become 0. Is it clear, friends? So then we also get one more term 0, that is cos y plus cos x plus y also become 0. So where we can see, now we're going to simplify this. I'll bring this cos x on the other side, so thus I will take this as cos, that implies cos x plus y is equal to, I will take this as minus cos x. Similarly in this case I will take cos y on right hand side, so therefore I will get cos x plus y is equal to minus cos y. Is it clear, friends? So one can easily identify that on both the sides here LHS is same. So therefore comparing RHS, we get what we get here, friends, that is minus cos x is equal to minus cos y. So that implies, it means that when this is possible, students, when the angles are same, so that is x is equal to y. So therefore I will put y is equal to x in this equation, that is in cos x plus y is equal to 0. So what we get here, friends, we get that cos x plus x, so it will become cos 2x is equal to 0. So one, we can easily identify that this is possible when we know that, what we know here, students, cos 2x, I'm going to take here 2 cos square x minus 1. So that implies, I will substitute in this equation, students, I will get here cos x as it is plus cos 2x, I'm going to take here 2 cos square x minus 1 is equal to 0, where cos x, and here I will get this as 2 cos square x minus 1. So please remember here, friends, what is cos x minus 1. Now I'm going to equate this such a way that I'm going to take this function as 2 cos square x plus cos x minus 1 is equal to 0. I want to find the roots of this equation, students. As you have studied about the quadratic equation, right? I'm going to compare this with ax square plus bx plus c is equal to 0. In this we can find the roots of this equation. Now same way I'm going to split this such a way that I will get back the same equation. So what I can substitute here, friends, 2 cos square I will keep it as it is. Keep in mind here, students, very important step. So here I'm going to take plus 2 times cos x. If I take 2 times cos x means I have to minus 1. Yes. So therefore I will minus 1 cos x minus 1 is equal to 0. So they are the same equation. Just I have split this as cos x. So now from these two equation, these two terms, what is common here? Yes, we have 2 cos x is common. So what remains? It remains cos x plus 1 remains. Similarly in these two, what is common? I will just take minus 1 is common, so I will take out minus 1, so it will be cos x minus 1 is equal to 0. So therefore here one can easily identify that 2 cos x minus 1, and what is common from this again remains cos x plus 1 is equal to 0. So what is 0? Either this part must be 0 or this must be 0. So that implies, I say that either of the one must be 0. So therefore I will take here this as, that implies 2 cos x minus 1 must be 0, or I say here cos x plus 1 is equal to 0. So I'll just simplify this now. 1 I will take it on right hand side, it will become plus 1, and this 2 I will take it in the denominator. So cos x I will get here, friends, it is 1 upon 2, or in this case I will just take minus 1 on right hand side, it will become minus 1. So therefore when x is cos x is 1 upon 2, so I will take here x is when pi by 3, this is true, and when it is minus 1, friends, you can easily identify it is for pi. So therefore we get two roots. So I say that thus pi by 3 and pi by 3 I have two roots, and similarly pi and pi are the stationary roots, stationary points. So like this we get the stationary point. So therefore immediately what, after finding the stationary point here, friends, we are going to simplify the a value. So let a is equal to f of x, which is equal to, I'll just differentiate this once again. So you know differentiation of x is already done in the previous slide, you can just go through it. I'll just differentiate this once again. So I will get here sin x minus sin x plus y. Is it clear? So similarly I will take b value. You know already b, it is f x y. So you know the formula, it is rho square x upon. So I will just simplify this here. I will get here sin x plus y. Similarly I will take c, which is equal to f y y. We already done. It is sin y minus sin x plus y. So like this I have calculated ABC. Now I will substitute at point. First point I will take, that is stationary point, pi by 3 to pi by 3. So let us see what is a value. So a will become minus sin pi by 3 minus sin. So here x and y are same, so pi by 3 plus pi by 3 it will become, yes friends, it is 2 pi by 3. If you simplify this, you get this as minus root 3 upon 2 and minus, again this is root 3 upon 2 only. Ultimately if you simplify, you will get this as minus root 3. So a we have got this as minus root 3. Similarly we'll try for b. Okay, so let us see what is b. So b is equal to, I'll just substitute here pi by 3, it will become 2 pi by 3. We know that pi by 3, but already we have done here. Same way I will take this as root 3 upon 2. Similarly we'll see c. I will substitute here minus sin. Same thing. So instead of here x we have y. So again x we have already done for a. Same way we'll do for y. We get minus root 3. So therefore let us check the value, the condition, that is step 3, ac minus b square. Yes friends, we can see very easily what is a is minus root 3 and c is minus root 3, then minus b, it is minus root 3 upon 2 square. Just substitute all the values. Easily you can find that this is equal to 9 by 4, which is greater than 0, and the condition says that a is equal to minus 3, which is less than 0. So hence easily we get the answer here, students, that is f of x comma y is maximum at pi by 3. Therefore you can find the maximum value, substitute it in the function. So you know the function f of x comma y, which is equal to sine pi by 3 plus sine pi by 3 plus sine, yes it is 2 pi by 3. So I will add pi by 3 plus pi by 3, it will become 2 pi by 3, which is equal to root 3 upon 2 plus root 3 upon 2. How many times, your students? Root 3 upon 2 plus root 3 upon 2, we get 3 times. So it will become therefore we get the maximum value. This is 3 root 3 upon 2 is maximum value. Is it clear? So let us try for next point, that is pi. So here very easily you can see, students, what is a. It is in terms of sine. So you can just see sine pi, again sine pi, 2 pi will get 0. So here a is equal to 0. Similarly if you see b, again you can see very in the equation, In the equation you can easily identify sine pi plus pi, again 2 pi, which is 0. Again in C, B is 0, C is also 0. So sine pi is 0 because sine pi is equal to sine 2 pi is 0. So therefore A is 0, B is 0, C is 0. So there is no need to remaining simplify. So this is how we solve the examples. So such examples are likely to come in the exam. Please prepare for the examination point of view. Then from this has already appeared in the previous exam. So all the best students. Thank you so much. If you like this video, please, if this information is important, please like, subscribe and share with your friends. Thank you so much.